Okay, so before this kita dah pun belajar IMF, kategori van der Waals forces. Okay, so for van der Waals forces ada dua. Kita dah pun cover dipole, and also London forces. Okay, so another category of IMF, intermolecular forces, adalah hydrogen bond. Okay, so for hydrogen bond, it is a strong permanent dipole attraction between positively charged hydrogen atom of one molecule and negatively charged small and highly electronegative atom, fluorine, oxygen ataupun nitrogen atom from another molecule. Okay, so ingat, ini masih lagi intermolecular forces, so maksudnya between molecule. Okay, so maksudnya satu ada hydrogen atom, satu lagi molekul, dia ada FON. Alright, so the hydrogen bond, let's say you have hydrogen fluoride here, one hydrogen fluoride molecule with another hydrogen fluoride. So, between these two molecule akan ada formation of hydrogen bond. Okay, and akan ada formation of hydrogen bond dekat sini jugalah. Okay, remember it is between molecule. Okay. Right, so macam mana nak ingat? So you have F, O and also N from another. Ini ada molecule. Okay, so another molecule yang lain, dia mesti ada hydrogen bonded to F ataupun O ataupun N. Okay, so maksudnya let's say you have H bonded to F. Okay, so lone pair daripada fluorine ni, so ni one molecule, ini another molecule. So this lone pair dia boleh buat hydrogen bond, okay, di sini, right? Ataupun let's say H bonded to O. So dekat sini boleh buat hydrogen bond. Okay, dengan syarat mesti phone salah satu, phone bond to hydrogen that directly bond to sama ada F fluorine ataupun H bonded to O ataupun H bonded to N. Okay, so this thing I've already explained in detail dalam Google Meet session. So go back to that recording. Okay, and untuk this video, okay, kita akan just recap. Okay, now let's have a look at few example yang ada hydrogen bond. So let's say you have one water molecule and another water molecule. So between this water molecule akan ada hydrogen bond dekat sini. So lone pair daripada oxygen atom dekat sini buat hydrogen bond with hydrogen that directly bond to oxygen. So syaratnya hydrogen atom tu mesti sama ada bond to fluorine ataupun oxygen ataupun nitrogen. Okay, so let's have a look at this example. Okay, so ini ammonia with another ammonia. Sama jugalah case dia. So lone pair daripada nitrogen buat bond dengan hydrogen that directly bond to nitrogen. Okay, so let's say kita ada kat sini water molecule with NH3 ammonia. Okay, so oxygen ada lone pair, dia boleh buat hydrogen bond with hydrogen that directly attached to nitrogen. So dia tak semestinya dalam satu molekul yang sama jenis, dia boleh juga from different molecule. Okay, as long as syarat dia mesti ingat phone bond to hydrogen that directly bond to FON. Okay, phone, handphone. So mesti ingat these terms. Alright, so let's say we have here, okay, so contoh kita ada CH4 dengan water molecule. So CH4 dengan H2O ni boleh tak buat hydrogen bond? Okay, so kita tengoklah. Does it satisfy this syarat trick yang Miss ajar just now? So you have lone pair daripada oksigen nak buat bond dengan this hydrogen. So tengoklah, hydrogen ini directly attached to which atom? In this case, carbon atom. So is carbon atom one of the handphone tu? Tak. So therefore CH4 tak boleh buat hydrogen bond with water molecule. Therefore kita boleh juga cakap CH4, which is methane, is not soluble in water. Okay, so kalau dia boleh buat bond with hydrogen bond with water molecule, maksudnya dia adalah soluble. Okay, so hydrogen bond also exists in organic molecule. For example, alcohol, ROH, okay, and carboxylic acid, C double bond O, OH, and also amine, ada N. Okay, and this is due to the presence of OH group ataupun kalau dalam amine dia ada N dengan lone pair lah. Alright, so as you already learned before, hydrogen bond is the strongest, followed by dipole-dipole forces, and the weakest is London dispersion forces. Okay, the strength of hydrogen bond is depend on the electronegativity of the element. So kalau ada fluorine atom means it is the most electronegative element. Therefore, anything yang ada fluorine, it will be the strongest hydrogen bond compared to others. Okay, tapi dia ada exception. Nanti kita akan discuss lah after this. Right, so hydrogen bond in alcohol molecule is stronger than amine with comparable weight, maksudnya with almost similar weight lah. Macam yang tadi kita discuss, maksudnya dia punya perbezaan weight tak terlalu banyak. And the oxygen atom in alcohol is more electronegative compared to nitrogen. Okay, so kita ingat balik. Dulu kita dah pernah belajar CNOF. So the most electronegative adalah fluorine, followed by oxygen, followed by nitrogen. Okay, so that is why kita explain beginilah, oxygen is more electronegative than nitrogen. Okay, so ini kita akan guna balik this basic concept dalam organic compound SEM 2 nanti. Now let's have a look at effect of hydrogen bond on physical properties. So kita akan discuss for boiling point, solubility, and also density of water and ice. Now let's discuss the trend of boiling point of the hydride for elements in group 14 until group 17. Okay, so the boiling point of hydride for group 14 elements. Group 14 kita ada carbon, silicon, germanium, and also tin. Okay, so all of these group 14 elements, okay, the hydrides for them, it shows normal behavior. Maksudnya you can see here CH4, the boiling point is lower than SiH4, and then followed by GH4 and also SnH4. Okay, so the type of intermolecular forces that exist between the molecule are only van der Waals forces. Okay, dia tak ada, there's no hydrogen bonding present. So kenapa dia tak ada hydrogen bond? Sebab syarat untuk hydrogen bond mesti FON bond with H directly bond to F ataupun O ataupun N. Okay, so ini satu molecule and this is another molecule. So untuk all of these elements, okay, group 14 elements, tak ada langsung FON, right? So there's no hydrogen bond present. That is why dia hanya ada weak van der Waals forces. Okay, so the boiling point increase regularly when the relative molecular mass increase. So ingat, bila mass increase, maksudnya kita tengok dari segi in terms of size lah kan, size increase. Okay, so bila size increase, therefore the intermolecular forces, van der Waals forces, stronger. Therefore you need more energy to overcome the forces. That is why boiling point increases. So next kita nak discuss group 15, 16 and also 17. Okay, so you can see here the trend. Generally, all of them akan increase in boiling point, kecuali untuk H2O, HF and also NH3. Okay, you can see the boiling point is higher compared to the other elements. So why is this? Okay, so kita discuss yang general dahulu di bahagian sini. So the increase in boiling point for hydride for each periodic group, it is due to the increase in van der Waals forces, sama macam yang kita discuss in group 14 tadi. Increase in size. Okay, so the boiling point will also generally increase. Okay, tapi tidak untuk these 3 molecule. Why? Okay, so you can see the boiling point of ammonia, water molecule and also hydrogen fluoride are higher compared to the other hydrides. Okay, so dekat bahagian sini you can see it is higher than others. Okay, so why is this happen? This is because of the presence of hydrogen bond between the molecule. So ingat, FON boleh buat hydrogen bond with H handphone. Okay, so water molecule, hydrogen fluoride and also ammonia, you can form hydrogen bond, okay, between the molecule, right? So that is why kita refer balik kepada strength of intermolecular forces. The strongest adalah hydrogen bond followed by dipole followed by London forces. So these two adalah van der Waals forces. Okay, yang paling kuat adalah hydrogen bond. Right, so kalau dia boleh buat hydrogen bond means dia punya intermolecular forces are stronger. That is why you need more energy to overcome the forces. That is why it will result in higher boiling point ataupun melting point and so on lah. Okay, right. So you can see here, contoh kita ada water molecule. Okay, so another water molecule, you can form hydrogen bond. Okay, dia boleh form hydrogen bond with another water molecule. So untuk HF pula, so ini satu molekul HF, ini another molecule of HF, so you can form hydrogen bond, okay, between HF molecule. So untuk NH3 pula, you can see here N, okay, buat bond, hydrogen bond with hydrogen from another molecule, and you can see here this hydrogen bonded to nitrogen. So syarat untuk buat hydrogen bond pas. Okay, so untuk all these 3 molecule, since dia boleh buat hydrogen bond, that is why the boiling point here slightly higher compared to the other hydrides. You can see NH3 has the lowest boiling point and H2O has the highest boiling point. Okay, so daripada graf ni kita boleh nampak dia punya value. Okay, so kita tengok balik dekat dia punya formation of hydrogen bond. So even though the fluorine is more electronegative than oxygen, so kalau kita tengok in terms of electronegativity, SINOF kan, fluorine yang paling elektronegatif tapi compared to oksigen. Tapi kenapa kalau kita tengok dekat sini, susunan dia H2O is the highest boiling point. Okay, why? Kenapa it is higher compared to HF? This is because kalau kita tengok dekat sini, molecule of HF, okay, ini another molecule of HF. So focus on the blue one. So this one HF, okay, dia boleh buat satu hydrogen bond with another. Okay, so dia hanya boleh buat 2 hydrogen bond. Kalau water molecule, so untuk water molecule, you can form 1, 2, 3, 4. So boleh form up to maximum 4 hydrogen bond. So okay, so now let's have a look at representation yang lebih jelas. Macam mana kita nak nampak one water molecule boleh form 4 up to 4 hydrogen bond. Okay, so untuk one water molecule here, kita fokus yang warna biru ni. Okay, so syarat dia mesti FON bond with handphone H that directly bond to F ataupun O ataupun N. Okay, so untuk this case H2O molecule, jadi tak ada masalah lah. Okay, just kita kena tengok berapa hydrogen bond dia boleh form. Okay, so you can see you have here 1, 2, 3, 4 hydrogen bond. Okay, which is more compared to HF hanya ada 2 hydrogen bond. So that is why water molecule will have higher boiling point compared to HF. Okay, so macam mana kita nak explain dalam bentuk ayat? So, first thing first, kita susun dulu ikut susunan NH3 ammonia, and then followed by HF, followed by H2O, and then gariskan increasing boiling point label. So, H2O able to form more hydrogen bond compared to HF. Okay, so tak perlu tulis H2O able to form 4 hydrogen bond compared to HF only able to form 2 hydrogen bond pun tak apa. You just state generally. Okay, H2O able to form more hydrogen bond. Okay, alright, so next. Okay, so kenapa kita letak susunan NH3 dengan HF begini? So this is because F, fluorine atom, is more electronegative compared to nitrogen. So hydrogen bond in HF is stronger compared to NH3. So HF is stronger than NH3. So kita nak tengok effect of hydrogen bond on the solubility of a simple covalent compound. Alright, so water we know it is a good solvent. So it is a good solvent for liquids, gases that contain small polar molecules. So water, it is also a polar molecule. And if the compound can form hydrogen bond with water, then it is said to be soluble in water. For example, here kita ada ammonia, NH3 with water molecule. So, kamu boleh nampak dekat sini akan ada hydrogen bond between H daripada ammonia and also oxygen daripada H2O molecule. And dekat sini akan ada another hydrogen bond between nitrogen and also hydrogen from water molecule. So, if the molecule can form hydrogen bond with water molecule, then we can say that it is soluble in water. Okay, most organic compound they are insoluble in water kecuali untuk beberapa organic compound such as amine, alcohol and also carboxylic acid. Okay, so for example, amine. Okay, so kalau kamu nampak dekat sini, example dia adalah ethylamine. So, you can see ada nitrogen dekat sini. So, this nitrogen boleh buat hydrogen bond with water molecule. So, it is said to be soluble in water. Sama juga dengan alcohol. In this case, untuk example for ethanol. So, ethanol ada oxygen dekat sini. So, dia akan jadi OH. So, this OH. Okay, dekat oksigen ini ada lone pair. So, this lone pair boleh buat hydrogen bond with water molecule. Okay, so ini dia punya hydrogen bond. Right, so for carboxylic acid, same as well. So for example here, kita ada ethanoic acid. So this part of OH, okay, O dekat sini ada lone pair. So dia boleh buat hydrogen bond with water molecule. So untuk this example, they are soluble in water. Okay, so as you can see here, example, they are soluble in water because this part of NH group, okay, dekat part sini, dia boleh buat hydrogen bond with water molecule. So you can see ada hydrogen bond. So we say that this amine is soluble in water. Alcohol and also carboxylic acid, they are soluble in water because of the OH group. So dekat OH group tu dia boleh buat hydrogen bond with water molecule, so we can say that it is soluble in water. But not all organic compound yang ada NH group and also OH group boleh jadi soluble in water. Dia ada beberapa exception case. So let's say kita ada alcohol. Tengah ni adalah dia punya hydrogen bond with water molecule. Okay, so kalau untuk in this case ini metanol. Metanol hanya ada satu carbon. So, this part yang akan buat bond hydrogen bond yang akan larut dengan air. Okay, this part, okay, hydrocarbon dia tak larut air. So, imagine kalau bahagian hydrocarbon ini besar. Contoh ada CH, let's say you have CH3, CH2, 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 CH2. Right? So, bahagian sini, your hydrocarbon part ataupun this hydrophobic part besar. Okay, so what happen to this part, dia akan jadi small in size. Okay, so bila bahagian hydrophobic besar, dia akan ganggu solubility of your compound itu dalam air. So the greater dia punya molecular mass, okay, dia akan it will make the compound will be less soluble in water. Oh, sama jugalah untuk amine. So kalau amine, this part adalah NH2, NH2 part yang suka air. So let's say here, this part adalah yang larut air. So bahagian belakang ini adalah yang tak larut air. So you can see ada 5 carbon. So kalau 5 carbon, rantai carbon dia panjang. So it will affect the solubility of this amine in water. Okay. So itu yang dimaksudkan dengan this explanation. As the molecular mass increase, okay, the polar of OH and also NH part will becomes smaller. So bahagian yang polar sini akan jadi lebih kecil. Okay, lebih kecil daripada yang bahagian hydrophobic tu lah. Right, so this will make the hydrocarbon, this will make the compound less soluble in water, since this is because of the hydrocarbon part yang bahagian lebih besar itu insoluble in water, yang hydrophobic tadi. Okay, the one I mentioned about hydrophobic part. Okay, this will make the solubility of the compound decreases. So, water molecule, it has the ability to form extensive hydrogen bonding network. So, let's say if you have liquid water, when it is cool to form solid, so the water molecule will arrange themselves. So, satu water molecule akan arrange themselves with another water molecule. So, dia akan buat hydrogen bond dengan molekul-molekul yang lain, yang di sebelah lah. Okay, so when they will arrange themselves to form a tetrahedral arrangement. So, you can see, macam yang tadi kita dah discuss, Satu water molecule boleh buat 1, 2, 3, 4 hydrogen bond. Okay, so dia akan maksimumkan space around the water molecule. So dia akan susun masing-masing hydrogen bond ni, dia akan susun dalam keadaan tetrahedral arrangement. Okay, so kalau bila banyak-banyak water molecule susun, dia akan jadi begini. Okay, so let's say this is one water molecule, as you can see here. So ini satu water molecule. So dia akan susun 1 hydrogen bond, 2, 3, 4. So kalau kamu nampak dekat sini, dia dalam keadaan tetrahedral. So water molecule yang lain pun dia akan susun dalam keadaan tetrahedral juga. So you can see here 1, 2, 3, 4. Right, so this one also dia akan buat tetrahedral arrangement. So bila banyak-banyak molekul susun with that arrangement, okay, so tujuannya apa? Untuk maximizekan the amount of hydrogen bond between them. Okay, so lama-kelamaan dia akan membentuk satu ruang di bahagian tengah ni. So this empty space yang kita panggil sebagai open space, right? So eventually dia akan jadi beginilah from the front view. So this is the empty space form, right? So okay, so bila terbentuknya this open space ataupun this empty space, ataupun kita panggil sebagai open structure. Okay, so the large amount of space between them is called as open structure. So this arrangement of molecule has greater volume than liquid. So maksudnya solid water dalam keadaan solid has more volume compared to liquid water. Okay, so that is why water will expand when it is frozen. H2O dalam keadaan solid, which is ice, in form of ice, they will have the open structure. So this will make the ice less dense than water at 0 degree Celsius. So ini water dalam keadaan liquid lah. But when ice melts, so macam mana daripada ice, okay, solid, dia jadi liquid. Okay, liquid water. So bila kamu bagi energy in form of heat, so ice itu akan melt. So maksudnya apa? You are breaking the hydrogen bond dalam ice tu. So this will allow the water molecule to be more compactly arranged, and this will result in decrease in volume. Okay, so maksudnya apa tadi? Kita dah break the hydrogen bond. So this open structure tu no longer exist lah, this open structure. Okay, so let's say kalau kamu bagi energy in form of heat, so kamu akan break this hydrogen bond. So sebab itulah bila ice tu dah cair, okay, dia tak akan lagi floats on water. Okay, maksudnya dia punya open structure tu dah musnah. You already break the hydrogen bond. Okay, and you already disrupt the volume. So when the volume decrease, the density will increase. So how? Density is equals to mass over volume. Okay, so it is a vice versa punya relationship. So volume decrease, density increase, ketumpatan pun meningkat. Okay, therefore water dalam keadaan liquid has higher density compared to ice.